All right, I wanted to give you an update to the belt-driven Sears tiller. Ran into a problem with the actuator, and this is the original actuator that you saw in the previous video. It's a nice sturdy actuator. The problem is the way it was mounted. This is an aluminum shaft, a hollow aluminum shaft, and it's a ball screw type setup. There's a steel threaded item that makes it go up and down, and with the pounding that the actuator took, it basically stripped out the aluminum threads inside the shaft. So as you saw in the previous video, this actuator was mounted from here down to here on a solid bracket. So there was no give, there was no flex, there was no pivot. So when the tiller was running, every vibration, if you hit a rock, if the nose of the tractor went up, it drove the tiller down and put a lot of stress on the actuator. So my goal was to find some way of making the actuator last longer. One idea was to get an actuator, and by the way, the new actuator has one big advantage in that it has limit switches. So it goes down so far and stops, it goes up so far and stops. The old actuator had a clutch setup to where it would go up until the clutch over torqued and stopped. It would go down, and if you did not physically stop it, it would thread the rod, the actuator, right out of the assembly. So you had to have a way of stopping, and then it would go down until it over torqued and the clutch would click. This, with the actuator micro switches, it goes so far up and so far down it stops. There's not any torque or pivot on this. And so we got the actuator. One idea was just to use a cable. So when the actuator is extended, the cable would flex. There wouldn't be any vibration into the actuator. It's a very good concept. There were two reasons why I didn't want to do that. One was my concern of the actuator pivoting and falling down into here. And the other issue was with this setup, which we'll get into a little later, is this setup allows for some shock absorber effect. When there's going to be times you only want to till maybe quarter or half depth because the ground is really hard or whatever the case might be. And with this setup, I'll show you here, you're actually allowed, I'm going to push on the tiller, down on the tiller, and it's not a lot, but you're getting about a quarter inch of flex there. And so if the tiller was to bounce up and hit a rock, this is going to buckle, and as it comes back down, you got a little shock absorber effect that I think is going to do really good on helping save this actuator. Now, how I built this pivot here is took some 1/4 inch steel, and it pivots here, and I actually moved I'm going to call it a saddle, moved the saddle pivot hole aft, so this would buckle down. When it wants to collapse, it's going to buckle this way. So this is 1/4 inch steel. This is a 1/4 inch screw, and this is 1.5 inch by 3/4 channel. But to start with, though, let's start from the top down. The actuator, when you buy the actuator, you're going to get everything from the fingernail up, minus the pin. You don't get this pin; you just get this. So the trick was how to get a rod to come out of this actuator. So what I did was I got I had an old come-along. If you look at the clicker type come-alongs in the saddle, you'll have a pivot that holds one of the hooks, and this is that this is the pivot right here. And what I used, I enlarged the pinhole slightly, and that's what this pin is going through. Before I installed this, I took it in dead center of this pin. I drilled and tapped a hole for a rod. And that, in effect, got me to the point where I had an actuator with a rod coming out of it. For the rod, what I did is I actually had spare parts from a ski binding. So this is a ski binding spring, binder spring, and I just reused the rod. One end was threaded. I cut it and put threads on the other end of it. So it's a smooth rod in here. This is threaded. That rod is threaded in to the come along pivot, and of course I have thread lock on that. And then obviously there's a nut at the other end that's holding this in. Back to the saddle here. To secure this in, these screws are actually free to pivot in this channel. And what I did was I drilled and tapped holes in. Excuse me, they're free to pivot in this in the flange here. But in the channel, I drilled and tapped holes. So these screws come in and they bottom out. The shank of the screw bottoms out right into this channel. And to make it a little more secure, I don't know if you're going to be able to see it, but I ground down some nuts and created some lock nuts. They're only 1/10 of an inch high, but surprisingly, you can tighten those screws into the channel pretty darn tight, and what's remaining of that nut, you can torque it down pretty good. I put it all together with thread lock, and since we're in the shear mode, I think that has more enough strength for what we're doing. Alright, so the intent was when this comes, when this gets extended, this is going to buckle down and then just pivot on this bolt. And the whole idea is just hopefully as you're tilling, the actuator is pretty much going to be along for the ride. The only disadvantage with this is, you have to a small degree, if you're in tough tilling in a tough area, you have to feather the clutch a little bit on the tractor to slow it down. Otherwise, it won't want to go as deep as you want it to go. And that is, so far, that has been a very minor problem. The advantage of this is that you're not, the old actuator you had to toggle up and down, and if the nose is coming out of the garden or you're hitting some uneven territory, you're toggling back and forth. And when this, we're going to till here in just a second, and when we're tilling, watch every time you see this this pivot up and down, that gives you an idea of how much stress and how much pounding the old actuator is taking when it was installed. And now this is free to go, and it does a pretty darn good job. So what we're going to do is go ahead and fully extend the actuator, and you'll see it come off the bolt, and there it's off the bolt. Okay, so now from here on out we're going to extend all the way down. We're going to extend it all the way down, and that shows you full extension there, and that shows you basically this thing from here on out the tiller is just going to be tilling away. Of course, if the tiller was on, this would sink further into the dirt, and it's going to free float until this comes up and hits this stop bolt again. So when you see these move up and down, you'll see that this isn't taking a pounding. So we're going to go ahead and take the actuator back up. Okay, and what we're going to do here is we're going to in a second we're going to start this up, and turn on the tiller, lower it into the dirt, do a little tilling, and once again, as it's tilling, see if you can see how much this flex, and you'll get an idea what the intent of this whole pivot's about. So let's go ahead and get her started. The only other thing I should mention is this tiller runs just a little low. It could be picked up further. You really got to balance the length of this length of this to how deep you want to till and how high you want to raise it. Right now it isn't a huge problem as far as being able to pick it up and transport it. When you do come out of a garden or you tilt, sometimes a tine will drag. It is a possibility, possibly of adding an over-center transportation link that would lift it up a little further. I think it'd pick up about another 3 inches, especially if you were going to be driving it into a trailer. You might want to add a little extra link that you could lift it up and hook, whatever the case might be. So hopefully this will give you some ideas on how you can do this and possibly improve what I got going here. So y'all have a good day.